So what we're going to be talking about today is circles. Now, in the first part of the notes, I talk about four things. I talk about the radius, and a radius goes from the center of the circle to any point on the circle. This little line is called your radius. And then I talk about area. Area is the amount of space inside a circle. And then I'm going to talk about something called a diameter. A diameter goes through the center, it cuts the circle half off. Anywhere. Literally, the diameter could be anywhere. Think of the diameter as 2 times your radius, because it's 2 of your radiuses. Or you can think of your radius as if you have your diameter and you divide it by 2, that's what a radius is. The formula for the area of a circle is pi r squared. Whatever your radius is, you just square it and you just leave the pi next to it. And the very last thing is called your circumference. And the circumference is like the perimeter of the circle. It's literally the distance around the whole circle. And the formula is, it's your diameter times pi. Or you can represent it as remember your diameter is twice your radius. Or you could say it's 2 pi times your radius. These are the 4 formulas for these parts of the circle. Sorry, my allergies are just going insane again, so bear with me. All right. Let's do some example questions, specifically with specifically with circles. If we know one part of the circle, we can figure out all 4. For example, let's say the area is 100 pi. We got to find your radius, diameter, and circumference. So remember, if your area is 100 pi, some number squared gave me 100. So what number squared, because area is your radius squared. It's the length of this center from here to here squared. So if this is 100 pi, your radius would be 10. Because if your radius is 10, 10 squared is 100 pi. If your radius is 10, your diameter is twice that, 20. And your circumference is 20 times pi. All right. Let's try another. Let's say your circumference is 8 pi. We got to figure out all 3 of these. Well, remember the formula for the circumference is your diameter times pi. Your diameter times pi. So your diameter is 8. Your radius is half of that, which is 4. And your area is 4 squared with a pi. Remember, pi is a value of 3.14. Sometimes it'll get a little tricky, and it might say your circumference is, let's say your circumference is 10. Now, if your circumference is 10, that means 10 is the same thing as if I divide 10 by pi, because look, they multiplied pi into it to figure out your circumference. So if I divide 10 by pi on my calculator, 10 divided by 3.14 more or less is approximately 3.18. So 3.18 pi is exactly the same thing as 10. So if they tell you your circumference is a number, they multiplied pi into it. Divide that by pi to figure out what it would be before you multiplied into it. And then, if you know your circumference, you know your radius is 3.18. And 3.18 divided by 2 is going to give me approximately 1.59, which is my radius. And my area is 1.59 squared is 2.53 pi. So these are different ways that they can present questions to you about circles. And that's good. You have to understand this for the next section that I'm going to talk about. The next section, the other thing of note, is called a sector. So think of a sector think of it like a piece of pie. It's a percentage of the area. Then I'm going to ask you in your notes, before we get into sectors, a sector is just a percentage of the circle that's of the area. Let's look at the first thing. If I break this into thirds, and I tell you, how many degrees is this? What percentage of the circle is shaded? If each one of these are broken into third, well, you would say 1/3 of the circle. How about if I have half of the circle? And if I were to ask you, what percentage of the circle is shaded? What's the area of the circle? Percentage-wise, you would say half of the area. How about if I said, this is a 90 degrees? You should say 1/4 of the area circle. It is 1/4 of the area is shaded. Now, if you don't know how these numbers were attained, in a circle there's 360 degrees. How many degrees is this arc right here? If this arc, and this arc are all congruent. Well, if I have 3 congruent arcs, each one of these is 120 degrees. And 120 degrees out of 360 reduces to 12/36, or 1/3. How do you know that this is 1/2 of the circle? Well, out of 360 degrees, 180 degrees are shaded. Therefore, the zeros cancel out. 18/36 is 1/2. How do I know that if I have 90 degrees shaded, it's 1/4? Well, I would say 90 over 360 reduces to 9/36, or 1/4. The reason why I'm bringing these up is because in the next thing of notes, I tell you how to find the area of a circle. You take the percentage that's shaded times the area. How did you find the percentage that was shaded just from a couple seconds ago? We took however many degrees we had shaded out of 360 degrees times the area of the circle, which is pi r squared. There's your formula for the area of a sector of a circle. All right, and then I give you a couple example questions. It's just awesome when you get to hear me blow my nose in the lesson. My allergies are just going insane. COVID, baby. Yeah, right, so lame. Anyways, if I ask you, if your radius is 2 and you have 90 degrees, find the area of this sector. This is the very first example question. Okay, well, 90 degrees out of 360 degrees that's shaded is 1/4 times the area of my circle. Remember, the area is pi r squared. So your radius is 2 squared. So this is going to be 1/4, which is the percentage, times the area, which is 4 pi. Now look, you're multiplying fractions. 4 pi is the same thing as 4 pi over 1. it might be easier just to say, here is your formula. Just put this over 1 because you're going to have to multiply it by the fraction. Anyways, when you do this, look, these 4's cancel out and you're left with pi. That's the area of a circle. Pi, you would technically say pi units squared because whenever we're talking about area, it's always measurement squared. Okay, now let's try the next example question. And they tell you, in this circle, they give you the circumference. If you were to go around this one time, it's called the circumference, and that equals 18 pi. This is the second example question in the notes. What's the area of this shaded region, which is called the sector of the circle? So in this sector, your percentage that's shaded is 180 out of 360 degrees, which is 18 over 36, or 1/2, times, okay, now we got to work backwards. If my circumference, coming back to this first page of notes, if my circumference is 18 pi, that means my diameter is just a number by itself, which is 18. My radius is half of that, which is 9. And the area is 9 squared. 18 pi, my diameter is just this number. My radius is half of this number. And then area is pi r squared, which is going to give me 9 squared, 81 pi. Now, if 81 and 2 don't reduce, so just leave it like this, 81 pi over 2. That's the area, 81 pi over 2. Let's try the last one. Now, for the last one, I want you to pause this video. It says the area that's shaded, which is the same thing as your arc length, is 30 degrees. Tells you your diameter is equal to 10, or this is 81 pi units squared, to be precise. Anyways, pause the video and see if you can find the area of this sector. Okay, if you paused it, you should have said 30 over 360 reduces to 3 over 36, or 1 over 12. This is 1/12. Because if you have 12 of these, 30, 30, 30, 30, 30, 30, it would make up the full circle. That's your percentage times, if your diameter is 10, your radius is 5, and your area is 25 pi. Combine these. 1 times 25 pi is 25 pi. 12 times 1 is 12, and it does not reduce, units squared. There's the area of that sector. Now I'm going to show you two things. The second thing is called the length of the arc. Think of like it's a part of the perimeter, but we don't say perimeter, it's the circumference. Let's say from here to here. This is called arc length, for example. Arc length figures out how long it is on the outside of the circle from one point to another. And the way you do it is this. If you're trying to find part of your circumference, part of it is the percentage of, which means times, your circumference. Your circumference is your diameter times pi. How do you find your percentage? Well, there's 360 degrees in a circle, and you're trying to find the percent out of 360 times your diameter times pi. And I give you two example questions. The first example question is, let's say this from here to here is 120 degrees, and your radius is 3. Find the length of this arc. The length of this arc from here to here is not 120 degrees. That's a degrees. That's what we're plugging in for here. We're trying to find the length if this is 3 units. So the first thing I would do is I would, same thing as I did before, 120 out of 360 reduces to 12 over 36, or 1/3. Times, remember I'm trying to find the circumference, which is my diameter times pi. If my radius is 3, my diameter would be another 3, which would be 6 pi. We're going to put it over 1. So think of the formula as this. Again, put it over 1. 3 and 6 reduced to 1 and 2. So the circumference, or I'm sorry, the arc length is 2 pi units. Okay, the very last question. If I tell you the amount of space that's in this circle is 100 pi, that means that this is the area. That means they did pi r squared equaled 100 pi. They figured out this formula. Well, I want to know what's the length of this arc if this is 170 degrees. Let's plug 170 into this. 170 over 360 reduces to 17 over 36. Now, times I need to find my diameter, throw a pi next to it. What number squared gave me 100? Or you could square root this. Anyways, the pi's cancel out. Square root of 100 gives me a radius of 10. So my diameter is 20 pi over 1. Now I'm just going to simplify this. I'm going to cross cancel. I'm going to divide both of these, let's say by 4. 4 is the biggest number. It's going to go into both of these. 20 divided by 4 is 5. 36 divided by 4 is 9. So I'm going to have my calculator, 17 times 5. 17 times 5. It's going to give me 85 pi over 9 units. Not units squared, just units. Circumference is just the distance. Boop. If I wanted to figure out the actual number, I would multiply 85 times pi, divided by 9 is going to give me a decimal. Anyways, two things. Sector of a circle and arc length.